Okay, number 13 and 14 pertain to this situation. 2015, a country had an adult population of 250 million, of which 160 were internet users and 90 were not internet users. 160 plus 90 does sum to 250, so it's breaking it apart. And of that adult population of 250 that used the internet, just 160, 52.8 million had accessed 2 or more times. Okay, so that's a conditional number there. We'll keep that in mind. 13, the question. The adult population in 2015 was 77% of the total population. So that means the number of adults equals 77% of, which is multiply, times the total population. Okay. Which of the following was the approximate total population? Okay. So we know that adult population is 250. 77%, I can quickly eyeball that and say that's roughly 3/4. Because I'm going to divide that to get my total population. Divide by 3/4 is my total population. Okay. Well, that means I'm really dividing by a fraction is like multiplying by the reciprocal. I know 1/3 of 250 is roughly 60 plus. So this is going to be 250 plus 60 plus. It's going to be something more than 310 million is my answer. Well, there's only one answer in that ballpark. It's C, 320 million. So yes, I could have used a calculator, but if I can manipulate my numbers more quickly and make close estimates, I can get exact answers without doing that. Calculators often take too much time. I suggest if you can, try to do the test and you find you can, the calculator test, without a calculator for almost the entire test, if not the entire test. Number 14, what fraction of the adult internet users in this country had access to or more? Okay, so our denominator, this is a conditional probability problem. Our denominator is not the full adults, it's the adult internet users, which is that 160 million number, okay? And the 2 or more access number was our conditional number of 52.8. So the correct fraction is going to be 52.8 adults that use the internet 2 or more times over 160 million adults that use the internet. Roughly, this is about, again, using estimation, 1/3. The only answer that's close to 1/3 here is B, 33 over 100. I could have used my calculator to punch it in exactly again, but really no need to get the exact answer. Okay, 15. If 10x plus 9 equals 9x plus 9, notice those quantities in parentheses are the same thing, plus 25. That means I could do 10x plus 9 minus 9x plus 9, which is 1x plus 9 after I subtract this side from this side. And that equals, the only thing left on the right side is going to be 25. The question asks, what's the value of x plus 9, which is 1x plus 9? Well, the value is simply 25. The correct answer for 15 is C. I could have multiplied it out, combined terms, solved for x, and then plugged back in x plus 9, but there was really no need in this case. 16. A biologist selected a sample of adult corner butterflies from the local population. The mean forewing length was 1.5 centimeters. The margin of error with this estimate was 1 centimeter, quite a bit relative to the actual measurement. If the biologist wants an estimate that is a smaller margin of error, I hope he would, it can be generalized to the entire local population. Which of the changes should be made when the study is repeated? Okay, so this is a problem solving and data analytics problem. There are only sort of 2-3 core key statistics concepts that come into play in this section of the exam. One of them is that all else equal, the margin of error will be less with the more data. Now, don't be confused to think that will tell you whether there's sufficient data to have a good study or the right margin of error. That we just simply don't know from the information given. And that's a typical trick they like to use sometimes on these types of problems, but not applicable here. What we do know is that the more data, the lower the margin of error. It decreases by the square root of n, or 1 over the square root of n. Not that you need to know that, simply more data, better or lower margin of error. So the correct answer here will be D. Selecting and measuring a larger random sample of butterflies. That will improve our margin of error. A, using a different tool, I have no idea. It doesn't say anything about the tools. Measuring the butterflies at different times. We know nothing about measuring them at different times above. Selecting and measuring only the butterflies that look the smallest. We don't know anything or the impact of that. There's just no information about that above. Simply, we're taking advantage of the concept. More data, all else equal, lower margin of error. Answer for 16 is D.